Okay, good afternoon. I'm going over another example of how to graph in standard form. So the equation we have is y equals x squared minus 4x minus 5. The first thing that you want to find is your axis of symmetry. To find the axis of symmetry, we're going to use the equation x equals the opposite of b divided by 2a. So something that I find helpful sometimes is first to identify your a, b, and c values. So I'm going to come back up here and do that. So my a value in this equation is 1. My b value is negative 4, and my c value is negative 5. So now I have those identified and I can use them when I'm doing my work. So x equals the opposite of b, which is negative 4, divided by 2 times a. The opposite of negative 4 is a positive 4. 2 times 1 is 2. 4 divided by 2 is 2. So my axis of symmetry falls at x equals 2. So I'm going to go and I'm going to draw a dotted line on my graph at x equals 2. So I find x equals 2 and I draw a dotted line, vertical line, at that point on the graph. Okay. The next step is to use your axis of symmetry to find your vertex, because your vertex always falls on the axis of symmetry. So what I'm going to do is take my x value, plug it into my equation, and simplify. So anywhere there was an x, I'm putting that 2 value, and then I will simplify. So my vertex is at 2, negative 9. So I'm going to go back to my graph. I'm going to put a dot at 2, negative 9. Your vertex will always fall on your axis of symmetry. The next point is also fairly simple to find. The next point that you should find is your Y-intercept. Your Y-intercept is your C value. So in this case, my C is negative 5. So my Y-intercept is 0, negative 5. So now I'm going to plot that on my graph. Over to 0, negative 5. Now it's important to find a few other points. When I look at my axis of symmetry, it's at 2, so I'm going to use 1, and I'm also going to use negative 1. Then I'll have a fair number of points that I can use to make my graph. So I'll go back to my original equation again, plug that in. So my equation is y equals x squared minus 4x minus 5. I am evaluating for x equals 1. So I'm going to substitute that in place and simplify. I will have a point at 1, negative 8. Plot that on my graph at 1, negative 8. Now I'm going to use the point where x equals negative 1. Move this up. Again, substitute into my equation and simplify. Because the negative is inside the parentheses, that becomes a positive 1. Here I have a double negative, so it becomes a positive. So now I have the point of y equals 0. So I have the point negative 1 comma 0, and I will plot that as well. So negative 1, 0. Now what I'm going to do in order to finish sketching my graph is I'm going to use the fact that there is symmetry in quadratic functions. So anything that is on the left side of my axis of symmetry is reflected across onto the other side. So because this point is 1 from the axis of symmetry, there's going to be another point on the other side with the same y value that's also 1 to the other side. Do that same thing here. So here I have to go 1, 2 places. So I'm going to go 2 the other way. And my final point up here is 1, 2, 3. So again, I'm going to go 1, 2, 3. Then I'm going to carefully just kind of draw my line, always putting arrows. And I've sketched my graph. I've identified my axis of symmetry is at x equals 2. My vertex is at 2, -9. This is a minimum. We're not going to worry about x-intercepts right now because we haven't covered that yet. Although we did find them on our graph, you could identify them, I guess. It's -1, 0, and 5, 0, but again, we'll look at that later. And my y-intercept was at 0, -5. So hopefully that helps you when graphing quadratic functions in standard form.